Back again with continuing on this module 6, question 5.7. So once again, this is our power triangle, or impedance triangle, sorry. So what do we got there? We've got 30 and 20. So you just do your squared A. That's 90. It's going to be square root of 300, 400. It's going to be square root of 1300. 36.05. There you go, that one there. 36. 30 squared plus 200 squared, 1300. Identify the following device. Right, this has got three terminals. 1, 2, 3. So it isn't a diode. It's not a diode. It's got to be an SCR because it's got three terminals. Okay, three terminals. 1, 2, 3. Three terminals. So it's SCR. Okay. Identify those components. Resistors. It's easy. Resistor. That one there is a diode. And these ones here are diodes as well. What kind of diodes are they? They're not Zenas and signals. They're small diodes. Okay. These are power diodes. Big ones. Power diodes. So let's see. How can a poor lagging power factor be corrected in installation? How can a poor lagging power factor? So we've got a lagging power factor, which is most of our installations are lagging, and we put capacitors in parallel with the supply. This one here. That's how we fix our lagging power factor. Calculate the resulting supply current. That's your square root. I'm not going to do it because it's easy enough. This one here, IS, is square root 9.1 squared plus 17.2 squared. And looking at it, if I drew it to scale, it's going to be about, can't be that one, can't be that one. It's one of these two. I'm going to guess. No, you're going to work it out. I reckon, don't know. Identify the electron indicated by the arrows. These are capacitors, electrolytic capacitors. They are diodes. Anode and cathode. That one there's the blocking one. So that looks like that way around. That line represents that, so that's the cathode. That's the cathode there, and that's the anode there. Diode above, what happens when the diode reaches its breakover voltage? When it reaches its breakover voltage, is probably about 0.7 or 0.6 volts. It's going to conduct. So the answer there is it's going to conduct. It's going to turn on. Define the time impedance of AC circuit. We've done that. AC circuit is the opposition to current flow in an AC circuit. That's impedance. Z equals V over I. Power factor of insulin is over 1. This is unusual. It's not very often our power factor is over 1. So normally our power factor is under 1. We put in capacitors, but if it's over 1, we have to put in inductors. Okay, to bring it down. If it's over 1, inductors. Under 1, capacitors. Over 1, inductors. Diagram. Let's have a look at it. Identify all the components. Box 1, 2, and 3. Rectify converts AC to DC. That's the bit we don't want. So this one here is a capacitor. Capacitor. What does that capacitor do? That one there will be for power factor correction. Capacitor. Power factor correction. Right there. That one there. Capacitor. Power factor correction. 2. This one here. Transformer steps down the voltage. See less windings? Okay, so transformer steps down the voltage. And 3. These are inductors and capacitors, and both of them are filters. Okay, so just remove that last bit of ripple. So inductor and capacitor, and they act as filters. So going over again, capacitor, power factor correction, transformer, step down the voltage, inductor and capacitor, filters. Look at this, and it's a regulator power supply, so we've pretty much got the same thing going on, just this end here. There's our filter, regulator, bridge, transformer, and this one here is a varistor. It's just surge protection, okay? So that, right, identify the two components within stage one. So there's only two things in there. There's the transformer and the varistor, surge protector. So it's going to be two components. So you're going to mark B and D. One component in stage two. Stage two is one component. You could put the other one says, you know that's a bridge rectifier. So there's a bridge rectifier. Okay, and two components in stage three, two components. We've got a voltage regulator, we've got a capacitor, and we've got a voltage divider with two resistors that sets up your, adjusts your voltage in. So what do they want to know? Two components. We have a reservoir capacitor with voltage regulator, so that's one of them, and a 2500 or 0.22. We just got to read it. I'd say it's a 0.22, is it? Oh no, 2500. There you go. So it's this one here, C and D. One component in stage four. Boom. Got a capacitor in the load. Stage four. That one there, smoothing capacitor. Following, it's a diode, it's either going to be a Zener or a signal. And you've only got a Zener to pick from, Zener. Power diodes, we've done that. Lots of these, inductive reactants, done those. Capacitive reactants, circuit currents, and then you just got to go V over it. We'll just do this one here quickly. So we've got to work out 6 Henry, 100 ohm, 50 hertz. So first of all, we've got to work out our XL. Two pi FL. Remember this? Because we've got 50 hertz, it's going to be 314 times L. 0.6. .188.4. So we've got a 1.8. Let's store this in. We've got an inductor, and we've got a resistor. That should be a coil, shouldn't it? Inductor and a resistor. This one here is 188.4. And we've got a resistor 100. Okay, that one there's in that direction, that one there's right angles. So then we work out our impedance, which is .4 squared. Do all that together, and that will give us an impedance of, let's do some quick calculations, 213 ohms. Okay, but what they want to know is the circuit current. I equals V over R, which equals 200 divided by 213. There's my R, or my Z in this case, Z, and there's my V. 200 divided by 213, which equals just under 1. There you go. Look at that. What is the circuit current? They want us to do exactly the same thing, but this one here, I'm not going to draw, I'm not going to go through it all. It's going to be the same thing. You're going to work out your C, your XC, okay, so that's my XL, and you're going to work out your R, and you're going to do your same triangle, square them. Done. We've done these questions. We're all starting to repeat, eh? Breakover, impedance, over one, inductor, done all this. Been through that picture. Nothing's changed. Same questions. Changing the dielectric material on the capacitor will affect its characteristics. Yes. Okay, same questions. Questions just keep repeating, eh? Breakover voltage. Yeah. Let's just roll through these, make sure there's nothing unusual there. Resistor, capacitor, diode, inductor. There's your inductor. What does peak inverse voltage mean? We went over that right at the beginning. Maximum voltage in reverse, impedance, two factors, poor power factor. Okay, poor power factor. What are you going to do? You're going to increase your current. You're going to have increased current. And you got, because you've got increased current, you're going to run bigger cables, bigger switchgear sizes, and you're going to get charged more for power if you're a commercial operator. Two factors. There's lots of factors there, okay, but currents will increase. Calculate the resultant supply. Done those. Easy. We got to the end.